Good day everyone, you're welcome to this channel, and in this video we're going to be discussing physics and projectiles. Now, a projectile is basically any object or body whose trajectory is a parabola. Trajectory is simply the path followed by an object in its motion. If a body moves in a circular path, it means that the trajectory of such a body is a circle. Or we can see projectile as an object which moves in a parabolic path under the influence of gravity. And in this video we're going to be deriving the equations which are important in solving all problems in projectiles. So this is basically what we need to know on this. The equations are built from Newton's laws of motion, or Newton's equations of motion. Now, we need to know that the motion of a projectile is analyzed in the vertical and horizontal direction. The motion of a projectile is analyzed vertically and horizontally. This is because when an object is thrown into air, for example a stone or a ball, the ball actually moves both vertically and horizontally. So at every point in time, the velocity of the body can be calculated, can be found. The velocity, its vertical displacement can be found, its horizontal displacement can be found at any point in time. Now, we need to know some few concepts here. We have what we call the range in a projectile, which is the maximum horizontal distance. We also have the vertical height or the peak height, the maximum height, okay? Or we call it the peak height, peak or maximum height. And this is the highest vertical displacement of the projectile. We also have time of flight, which is the time taken from the point of projection to the point where the object hits the projection plane. So in this video we are going to prove that the path followed by a projectile is actually a parabola, and we're going to have some defining equations. Now, let's say this is a velocity at any point in time. Now, we're going to have that the vertical component of the velocity is Vy, while the horizontal component is Vx. And if such an object is thrown at an angle, definitely we are going to have theta somewhere here, and this is also going to be theta. So, resolving our components, horizontal component will be cos theta, while the vertical component will be sin theta. Because if this is theta, the vertical component is actually opposite theta. So this is going to be resolved with sin theta. And this is going to be resolved using cos theta. So, briefly, let me rewrite the equations of motion which we are going to use to derive or prove that the trajectory of a projectile is a parabola. Now, from Newton's equations, we have that. Let me clean this. We have that V equals, let me use a black marker. V equals U plus AT. We also have that S equals UT plus half AT square, and we have V square equals to U square plus 2AS. We also have S is equals to U plus V over 2 times T. But for this class, we're not going to be needing the last equation, so let me just take it off. Now, I want you to know that these equations can be solved for the vertical and horizontal component as the case may be. So, I'm going to pick each of these equations and then write down its vertical and horizontal component. So for the first equation, we have that Vx is equal to u cos theta plus, now when we are dealing with gravity, of course we're going to be talking about acceleration due to gravity. So this becomes gt. Now I want to make a point clear, and the point is, when we are analyzing motion in the horizontal direction, such a motion is not affected by gravity. As such, we are going to take out the term bearing the gravity equation. Now, this is the point I'm talking about. We're not going to have gt because motion in the horizontal direction is not affected by gravity. So, all the components bearing x, there will be no gravitational force term. There will be no gravitational force applied to it. So, this is going to be given as velocity in the vertical, in the horizontal direction will be given as u cos theta. As simple as that. Now, vertical component of the velocity will be given by u sine theta. Now, because motion of a projectile is usually against gravity, it's moving against gravity. So I'm going to use a negative sign, gt. This is the vertical component of the velocity. Let's come to the second equation. Like I said, the motion of a projectile is in both vertical direction and horizontal direction. So I'm going to have, for the horizontal distance, I will use x. X equals u cos theta t, because I told you for the vertical, as you can see, we are using cos theta to analyze it. Of course, theta must be involved because we are talking about the motion of an object at an angle to the horizontal. So this becomes u cos theta t, and this is horizontal motion. So gravitational force term is not taken. As you can see, I'm bringing out my equation from these three basic equations of motion. Now, for the vertical distance, we have u sine theta t minus half gt squared. Then finally, on this equation, we have v squared x equals u squared cos squared theta. This is again vertical component of velocity, and vertical motion is not affected by gravity. So I move on to the horizontal velocity. Motion is not affected by gravity. So we move on to vy squared equals u squared sine squared theta minus 2gs. So these 6 equations are enough for the solution of every problem in projectiles. So this is how we derive these equations, and they are basically gotten from our Newton's equations of motion. As you can see, the difference between this and this is that we analyze this motion vertically and horizontally, and then we included theta because it's motion at an angle. So this is our toolkit. This is the equation we need for the solution of every projectile problem. And in my next video, I'm going to solve some questions on projectile using some of these equations. So I want to show that the trajectory of a projectile is a parabola. Now, and here we go. So we are going to do our derivation using 2 of these equations. Very simple and straightforward. So I'm starting with this equation. The horizontal distance is given by x equals u cos theta t. Okay? So this is the equation we're going to use to get the horizontal distance of a projectile at any point in time, at any specified time, given the angle of projection and given the initial velocity. Now, let me remind you that the symbols are the same, as you all know. V stands for the final velocity, U the initial velocity, A acceleration, T time, S distance. Same notation. So here we go. Now, making T the subject here, it's a very simple derivation actually. We divide both sides by U cos theta, U cos theta. And T becomes X all over U cos theta. So let's call this equation 1 and let's call this equation 2. Now, we move on to the equation that is needed for getting the vertical distance of a projectile. So we have that y equals u sine theta t minus half gt squared. So this is what we have. Now, simply put, we are going to be substituting t into this equation, and that's all. So I'm going to be substituting t into this equation. So we have that y equals u sine theta. Instead of t, I'm going to have x over u cos theta minus half g. We have t squared. So this is going to be substituting for t. Okay, so this is going to be y equals u sine theta x over u cos theta minus half g. We have t squared, so this is going to be x over, instead of t squared, we have x over u cos theta all squared. So this is what we have. And this is going to be y equals u sine theta all over u cos theta. I can have x outside the bracket. So this is going to be minus half g x squared all over, squaring everything in the bracket, x is squared, and then we have u squared cos squared theta. So this is what we have. Now, u cancels u, and from our trigonometric identities, we have that tan theta equals sine theta all over cos theta. So this becomes y equals sine theta over cos theta becomes tan theta. Tan theta x minus half g all over u squared cos squared theta. I can take out my x squared, and this is what we have. Quite easily done. So we have y equals tan theta x minus half g all over u squared cos squared theta x squared. Now, looking at this final equation, this looks like the equation of a parabola, okay? A quadratic equation, okay? That's the basic form of a quadratic equation. Of course, we have the x squared term, and you know that a quadratic equation is given as ax squared general form. So you can see that our a term here is the whole of this, and this is actually the equation of a parabola. So we have succeeded in proving that the trajectory of a projectile is a parabola. Thanks for watching, and see you in my next video.